Hello viewers. So in today's class we are going to take up some uh, important problems on conditional probability, right? So here I have written two formulas related to the conditional probability, and we'll use these two results in solving the problems, right? So the first one is the conditional probability of A when B has already happened is given by P A intersection B divided by P of B, right? So here we have the probability of A and B divided by probability of B, right? Similarly, here we have the conditional probability of B when A has already happened, and this is equal to the probability of A intersection B divided by probability of A, right? So here A and B are two events associated with the random experiment, right? So let us solve some simple problems related to these two results. So let us take this first problem. Here we are given A and B are two events such that the probability of happening of event A, that is PA, is given as 0.6 and PB is given as 0.3, right? And PA intersection B is given as 0.2, right? Now we have to find the conditional probability of A when B has already happened, right? So the formula for finding out P of A by B is given by this. So this is P A intersection B divided by P of B, right? So the probability of A intersection B is 0.2 and the probability of B is 0.3, right? And this is 2 by 3. Similarly, the probability of conditional probability of happening of B when A has happened is given by this formula. So we have P of A intersection B divided by P of A. Now substituting the value of probability of A intersection B as 0.2 and probability of A is 0.6. This is 2 by 6, so we have 1 over 3. So this is how we find the value of these two quantities. Now let us take the second problem. Here we have the probability of A as 6 by 11, probability of B as 5 by 11, and probability of A union B is 7 over 11. Now we have to find these three quantities. So here we have to find the probability of A intersection B, right? So here in the conditional probability of A, it depends on the probability of A intersection B, and here also we have probability of A intersection B. So it means our aim is to find out this value, right? So in order to find out this quantity, we'll make use of the theorem of addition. So addition theorem on probability is given by PA plus PB minus PA intersection B is equal to P of A union B, right? So here PA is 6 over 11, and this is PB, this is 5 by 11 minus PA intersection B, and the probability of A union B is 7 over 11. So this is 6 plus 5, 11 over 11, that is 1. 1 minus PA intersection B is equal to 7 over 11. So the probability of A intersection B is 1 minus 7 over 11, that is 11 minus 7 over 11, that is 4 over 11, right? So once we have obtained the value of the probability of A intersection B, we can easily find out this quantity and this quantity. So P A by B, that is conditional probability of A, is given by P A intersection B, and P A intersection B is 4 by 11 and PB is 5 by 11. So we can write it as 4 by 11 times 11 over 5. So 11 and 11 get cancelled, so we have 4 over 5, right? Similarly, the probability of happening of B, the conditional probability of B is given by P of A intersection B, and A intersection B is 4 by 11, and P of A is given by 6 by 11, so we have 4 by 11 multiplied 11 over 6. So we have 11 and 11 get cancelled. This is 2 2s are 4, 2 3s are 6, so we have 2 over 3. So the value of PA intersection B is 4 by 11, and P of A by B is 4 by 5, and P of B by A is 2 by 3. So this is how we solve these problems. Now let us take one more problem. So here we have to calculate the value of P A union B, and we are given 2 times of probability of A is equal to the probability of B is equal to 5 by 13, and the conditional probability of A when B has already happened is equal to 2 by 5. So here from this expression we can write 2 times of probability of A is equal to 5 by 13, that is equal to P of A is 5 by 26, right? Similarly, the probability of the event B is given as 5 by 13, right? So this is equal to 5 by 13, and if we take 2 to the denominator, we'll get 5 over 26, right? Now let us apply this rule, right? So if we take this formula, then P of A by B is P of A intersection B divided by P of B, right? Now the probability, the conditional probability of A is given as 2 by 5. So here we have 2 by 5, and here we have P A intersection B, and PB is equal to 5 over 13, right? So now we can write this as 2 by 5 is equal to 13 over 5 times P of A intersection B, right? So this is 5 and 5 get cancelled, so we have P A intersection B is 2 by 13, right? But we have to find P of A union B. So here again we'll apply the addition theorem on probability, the addition theorem, and the addition theorem says PA plus PB minus P of A intersection B is equal to P of A union B, right? So we'll substitute the values of P of A is 5 by 26, PB is 5 by 13, minus P of A intersection B is 2 by 13, right? And this is PA union B. Now if we take the LCM, we'll have 26 as the LCM, so we have 5 plus 10 minus 4 is equal to P of A union B. So this is 15 minus 4, that is 11 by 26. So the required value of the probability of the event A union B is 11 by 26.